Good afternoon. Let's take a look at the factor and remainder theorem. The remainder theorem states that the remainder when a polynomial expression is divided by ax minus b is the value of the expression when x is equal to b over a. In a bit we will look at the meaning of the remainder theorem, but first of all let's take a look at the factor theorem. This one is used most of the time. If the value of a polynomial expression is 0, so the value of the polynomial expression, so it is equal to, if it is equal to 0, then when I plug in x is equal to b over a, then ax minus b is a factor of the expression. So in order to take a look at this example and to see what it means, let's take a look at the following. They tell us to fully factorize the following expression. So if I want to factorize this, I do not have a factor. I don't know where to start to factor this cubic. So what I want to do is I want to say, sure, let's use the factor theorem. So there could be any type of factor here. For example, maybe x plus 1 is a factor, or maybe x minus 1 could be a factor. What about x plus 2 as a factor, or x minus 2 as a factor? So my factor theorem states the following. If I have x plus 1, I want to make x the subject. In this case, I'm going to say x is equal to negative 1. So if I plug in the value x is equal to negative 1 into my polynomial, I will find the result. If it is equal to 0, then I know that x plus 1 is a factor. So let's go and try this. I'm going to say negative 1 cubed plus 2 times negative 1 squared minus negative 1 minus 2. Negative 1 cubed is of course negative 1. So negative 1 squared is going to become positive. So positive 1 times 2 is plus 2. This becomes a positive and this stays a negative. So now I have here negative 1 plus 1 plus 2 minus 2. So this is equal to 0. So I see that the result is equal to 0. Therefore, x plus 1 is a factor. Now, I can go and I can try any of these to continue to find other factors. But since I have one factor, I can now use polynomial long division to find the remaining of the factor. So I'm going to say x cubed plus 2x squared minus x minus 2 divided by x plus 1, because x plus 1 is a factor. So I can divide this by the factor to find the remaining factors. So if I'm going to use polynomial long division, what do I have to do with x to become x cubed? I have to multiply it with x squared. So x times x squared becomes x cubed, plus 1 times x becomes plus x squared. I'm going to deduct this, and I'm going to get 0. 2x squared minus x squared becomes x squared. I'm going to bring down the next term. In this case, it is negative 1. What do I have to do with x to become x squared? Plus x, positive x. So x times x becomes x squared, plus 1 times x becomes positive x. If I deduct this, x squared minus x squared becomes 0. Negative x minus x becomes negative 2x. And I'm going to bring down my last term, in this case negative 2. What do I have to do with x to become negative 2x? I have to multiply it with negative 2. So here negative 2x, 1 times negative 2 is also negative 2. When I deduct this, I'm going to reach 0. So I know that, okay, if I divide my polynomial by a factor, it should give me 0 from the factor theorem, and this is the remainder, or this is the remaining factor. So I can say, let's start writing it out. X cubed plus 2x squared minus x minus 2 is equal to, and now I want to break it down into its factors. I know that x plus 1 is a factor. The remainder, in this case, is x squared plus x minus 2. Not the remainder, the other factor. Now, I can try to factorize this. Luckily for us, it is a very easy and simple quadratic. So if I want to factor this, I can just say, sure, x and x. In this case, it's going to be x plus 2, x minus 1. And I have my three factors. So the first thing I want to do is I want to test. So you can choose any random one. It is preferably to start with x plus 1 or x minus 1, and then I make x the subject, I plug it in. If the result of the expression is equal to 0, I know that it is a factor. Once I have one factor, I can use polynomial long division to find the remaining factor. Then I can factorize as far as possible. For the following question, we're going to require both the factor and the remainder theorem. We notice that it's a non-calculator style question, so we will have to do it by hand. So they tell us that this polynomial expression has a factor of x plus 2. So if we know that x plus 2 is a factor, then we make x the subject. In this case, x is equal to negative 2. If I plug in the negative 2 in the value of x, then this expression should be equal to 0. So let's go and do that. 6 multiplied with negative 2 cubed. Remember, I plug in the negative 2 in the place of x, plus a multiplied with negative 2 squared, plus b multiplied with negative 2 plus 8. And we know that since this is a factor, if I plug in the factor negative 2, then this should equal to 0. So negative 2 cubed is negative 8. 6 multiplied with negative 8 is negative 48. Negative 2 squared is 4, so plus 4a minus 2b plus 8 is equal to 0. Negative 48 plus 8 is negative 40. We're going to add 40 on both sides. So we are left with 4a minus 2b. We're going to divide both sides by 2. So we get 2a minus b is equal to 20. This is the first expression that we get. So we want to leave this expression in terms of a and b, or alternatively, if I wanted to, I can make b the subject. So 2a minus 20 is equal to b. This will be easier later when we're going to substitute the value of b into the next expression. They also tell us that the polynomial expression leaves a remainder of negative 3 when divided by x minus 1. So we know that if we're going to divide by x minus 1, in other words, if I make x the subject, x is equal to 1, if I plug this value into my polynomial, then the remainder is negative 3. So let's go and do that. 6, so instead of writing x, I'm just going to plug in a 1 here. So 6 multiplied with 1 cubed plus a multiplied with 1 squared plus b multiplied with 1 plus 8. And since we are using the remainder theorem, we see that the remainder is negative 3. So I am going to write here negative 3. We can simplify this expression, and this is simple because 1 cubed is 1 cubed is 1, so 6. So let's just go and write it out. 6 plus a plus b plus 8 is equal to negative 3. I can simplify all of this and I am left with a plus b is equal to negative 17. Again, let's make b the subject. So b is equal to a minus a minus 17. So since b is the subject in both of these cases, now I can just set my first expression equal to my second expression. So 2a minus 20 is equal to negative a minus 17. I am going to add an a on both sides, so 3a is equal to, and I'm going to add a 20 on both sides, so is equal to 3. Then I'm going to divide both sides by 3, so a is equal to 1. Now if a is equal to 1, I can use either of these expressions, it doesn't matter. So b is equal to negative, and I plug in the value for a is equal to 1, negative 1 minus 17. So therefore b is equal to negative 18. So if I look at my original question, they told us to find the value of a and b for 5 marks, and we have found the value for a and b. In this case, we needed both the factor and the remainder theorem. We were left with 2 expressions or equations, and then we solve them simultaneously in order to find the values of a and b.